presenters today, Isha, Mehra, and Shreya, Punya. They've both gotten their bachelor's in statistics and machine learning from Carnegie Mellon, and they were also TAs for some of the computer science classes there. And Isha is currently working as a data scientist at Facebook, and Shreya is working as a data scientist at Instagram. And with that, I'll hand it over to you guys.
Awesome. Yeah, hi, it's good to see some familiar faces from the session earlier. And like he said, we both work as data scientists at Facebook and went to college together. And we really wanted to create this talk today to pass on some of the guiding principles that we've learned in our 2 years as working in the industry that we wish we had learned while we were still studying.
Cool, so let's start with a really easy question. What is the role of a data scientist? There's a lot of answers to this, so we'd love to get an idea from the audience of what you all think being a data scientist really means. And this can also help us understand like what you all are looking forward to in this talk. So if you type in the poll link at the top into either a web browser or on your phone, then you should be able to go into the poll and generate answers, and it'll show up on this slide. So please start doing that now. And also let us know if you have issues with it, if there's any technical issues. Yep, starting to see them come in. Yeah, so I definitely think these two that just showed up are definitely like M3 are super important to the role. We want to perform analyses. We definitely want to solve some problems and do something useful for it. Sometimes we need to find patterns in the data and really like understand and interpret like weird information that we're seeing and like really put it all together into a finding. Yep, finding patterns, definitely. Know what best to do with data. Yep, you definitely need the technical skills. That's why we're the experts on data. Non-obvious patterns, yeah. Correlations and trends, yep. Predictions, yeah, improve processes. Yeah, sometimes you're not improving a product, you're also just improving the process. Yep, and real world applications, definitely. So I think these are all some really great answers. So I think it is a good time to proceed. So at a high level, we think data scientists are the arbitrators of truth. We know the data and we are technically the experts on the data. So it's our job to really tell people what the truth is and help them make these decisions. However, there are many types of data scientists. As you guys have probably realized even today in many of the talks, like data scientists have a lot of different jobs. This could be anything like product analytics, machine learning, data infrastructure, modeling and forecasting. These are all different archetypes that people can take on depending on what your interests or skills are. And then within these roles, there's a lot of outcomes you can drive and a lot of different skills you can build. So some examples would be like goal setting, experimentation, ranking model improvement, data cleanup, business strategy. These are all things that we even talked about in the previous slide. So there's a lot of different archetypes, and every role can honestly have a huge variety of all of the things that we just listed, depending on what you're interested in and what outcomes you're trying to drive. So today we'll be mostly focused on product analytics because that's the archetype at Facebook that Isha and I work in.
Did she freeze for anyone else?
Risk evaluation. There's so many other parts to this role and archetypes you can take on depending on your interests or the team you're on.
Awesome. Cool. Now we're going to look at, the steps needed to develop an analysis. So we want to open it up to everyone in the audience again and ask, what do you think the first and the most important step is of any analysis?
Cool. So follow the link again, and we'd love to hear what your thoughts are. Data cleaning. Yeah, that's definitely an early step. A lot of data requires cleaning. Seeing a lot of repeat answers. Any other thoughts?
Yeah, after you clean the data set.
Or before, maybe there's other.
Yeah, true.
Definitely. Context is super important to any data science job. Select features. Domain knowledge. Cool. So these are all really good answers. So we believe that the most important part of a project actually is scoping the project itself. So taking a little bit of a step back, you have to ask yourself, what are you really trying to look into? Why are you doing this project in the first place? So we like to start with developing a hypothesis. You can do an analysis that digs into a bunch of different pieces and like goes down a rabbit hole, and you'll never know when to end if you don't have a very specific question that you're trying to drive. So we recommend developing a hypothesis and really injecting like an opinion or an idea or something even that you've heard or like seen before, and trying to really like understand if this is true. So some example would be like, usage is low for these users because blah, blah, blah. Or we can improve this ranking model by blah, blah, blah. You should really like have an idea of like what you're trying to achieve before you start an analysis. And then you want to use those hypotheses to start breaking it down into more specific questions. So first you have to understand, how would you validate your hypotheses? If you could really understand any questions, what would those questions be? And then also, what outcomes would those questions drive? The most important thing your analysis can do is actually drive a tangible outcome in the business, either through a product or process. If your data just tells people a lot of interesting stuff without any outcome, then it probably isn't as important for you to work on. So we really recommend prioritizing, because you could honestly, like as a data scientist, there's so much work that we could do if we had boundless time, but we don't. And then brainstorm dimensions and analysis techniques. This is when a lit review is really useful. Start thinking about what sorts of dimensions you would cut the data on, what sorts of techniques that you've seen in other analyses that you would want to use, and what can you do with it in this analysis. And then last, ask for feedback. There's going to be so many people who are interested in your analysis, people like PMs, engineers, even like leads, like company leads. So if you ask for feedback, you can really get to understand what did they care about that maybe you had a blind spot on.
Awesome. So after you've finished your first step of actually scoping out your project, the next step is to find what your story is. And so the beginning of this is your exploratory data analysis. Really learning about the data set and getting to know it is super important. And this can be as granular as actually looking at the first 100 pieces of data in your data set and looking at examples of what they're like and making sure you really understand every single column in the data set and how it comes to be. And then next, you really want to summarize your entire data set. So figuring out those beginning summary statistics are really important, and mapping out all of your initial variables, making sure everything looks normal. All of these provide you a really good foundation for understanding where your data is supposed to lie, and also making sure your stakeholders understand where that data is supposed to lie. And lastly, if you are choosing to sample data, it's also really important to make sure that sample is a good representation of the rest of your data set. So this also is through summary statistics, through EDA, but you just want to make sure that the analysis you perform is going to fit in with the entire data set.
Cool. So the second part is following your notes. So you have to remember that all data is useful. So if you are looking into something and like you really cut it and then suddenly realize like the key questions or hypotheses you had don't really seem to fit the data that you're finding, that's still useful. Like maybe there's more there. A lot of the times you won't find data that you expect, and you really need to follow your instincts, and you need to use that information to guide follow-up questions. So if you think there's more there, then maybe you'll find something that no one even realized about the product or about the model or whatever you're working on. So sometimes it's really about following your nose and figuring out what interests you, because sometimes those are the most meaningful analyses. And then the last step, and then step 3 is telling the story. So after you do a whole analysis, you find some really interesting stuff, you have to really explain it to key stakeholders in a way that they can really break it down and figure out what the key takeaways are. So what I like to do is I ask myself, if I had to reduce my entire analysis down to 3 or less data points, what would this be? And that could be even like sometimes you have to take out the summary statistics if they don't really like drive a key point. You have to think about, if someone who wasn't a data scientist was to look at this, would that information that 7% of users take X action actually be interesting to them? Or they want to know more about ways they can improve the product? Like, what are the opportunity gaps? How do we compare to another project? Maybe we should deprecate something. So if you really had to reduce it down to like 3 pieces of information or takeaways, how would you do that? And if you can't do that, then how would you change your story or visualizations? Sometimes we try to pack in so much information that sometimes it's not even useful because people don't know where to look. So think about ways to frame it up into those key takeaways and really like represent the data is super meaningful.
Awesome. Yeah, and so now we're going to talk a little bit more about visualizations because they are such a great tool for telling a story and for getting your 3 main points across, especially when you use the best practices. So to begin, we want to ask, what visualization strategies can you use to ensure that each graph has a complete independent takeaway? So we believe that a graph should be a standalone story on its own. If you were to just hand it to your stakeholders, they should be able to understand what your takeaway is and also relay it to somebody else. So to begin, labeling your graphs. So this means your title, your axes, making sure that everything is really clear, especially making sure your axes have units. Like, this happens more often than you think, that people don't include units, and they're really, really important, even just to understand what your graph means. Next, you can use annotations. So annotating the numbers in your chart or the specific data points, as well as if you're trying to have your users take away that a certain point has a spike or a certain date had irregular behavior, actually just drawing a line on your chart, writing directly over it, I think it really helps the users figure out where on the chart they're supposed to be looking. And you want to make that really, really easy for them. And lastly, a 1-sentence takeaway. So this is a really good practice as well, is to include what the caption is or what the story that whoever is looking at your chart should be taking away. And you can put this underneath the title. You can embed it directly in your graph, or you can kind of use it as a caption underneath. But it's also a really strong tool. And lastly, a lot of the times the best chart will be a simple one. And so that's important not to forget, is that do whatever is best for the data, but you can also feel free to get creative with your chart types and really think, with the data I have, what is the best way to display that data? So we pulled a couple of examples, but definitely want to reiterate that sometimes a simple chart is the best chart. And now that you have found your story, now that you've created some visualizations, you really need to state your case for what you have discovered and why it should be important and what changes should be made. And it's important to remember that at the end of the day, your work is about the output and not the process. So when you are writing up this analysis, you shouldn't be writing about the process of how you came to your numbers, but rather what the output means and what changes it should encourage in your business. So for stating your case, because this talk is about storytelling, we wanted to explain this as if it was a story. So the first part of your story is the settings. So what is the context of your analysis? What's the background? Why did you decide to do it? What was your plan going into it? And what did you hope to find, and how would it affect the settings? Next is, who are your characters in your story? So who are the key stakeholders that will benefit from the analysis, and who are the stakeholders that you're presenting to, as well as who will actually be affected by whatever changes you make? And lastly, the events. So what insights did you find? What patterns did you find? What did you observe, and why do you think it's happening? And yeah.
Cool. So now that we gave a brief idea on how to write an analysis, how to go about driving insights with data, we want to go through a few examples of what the process actually looks like. And keep in mind, this is very product analytics focused. So we're going to put you in a mindset of being a data scientist at a firm similar to Facebook. So for the first example, your PM at Twitter asks you to identify ways to grow engagement on the app. They hypothesize that getting people to follow accounts can drive engagement. What key questions would you ask in your analysis? And remember from our scoping slide that these key questions should really guide how you break down the data and like what methods you follow up with. So think in terms of like, how would you really solve this problem? And how would you either validate or disprove this hypothesis?
And questions you'd ask to grow engagement, that's a really good example of something that could come up in an interview. So feel free to use this as interview practice as well.
What makes people follow accounts? Definitely, yeah. Yep, what kind of data do I have access to? Following which accounts has led to growth in the past? Yes, definitely think you should focus on like, where is this true and where is this not true? Because no hypothesis is perfectly correct or perfectly not correct. You should really think on that granular area. What sorts of demographics? Yep, also like focusing on like specific areas. What platforms can Twitter access to increase engagement? Yep. Whether the users are bots. That's definitely true.
Yeah, that's a good one too, because anytime you do have a data set, you need to think about whether you can even count all of your data as engagement. So
yeah, and these next two about interactions with accounts that follow, I think that's really important. Sometimes you can drive something like follows, but do you really drive that downstream impact that you care about? Sometimes a lot of people get caught up in that like first initial step, like we got our goal, we drove follows, but is it really like net positive for the users in the app? And as data scientists, we are the source of truth. We are in the position to like really like ground people and tell like, hey, like this is not driving the outcome we want, so we should do this instead. So it's okay to be like, no, your hypothesis is incorrect. And I think that's a good example of like looking into the actual quality. Awesome. I don't see any more coming in, so I'm going to move on to the next example. Oh, what type of news is creating more engagement? Yeah, looking at types of content, not just types of users, is definitely important. Cool. So the next question. So now we have to think back to our visualization best practices. Your coworker at McDonald's shows you a visual that they made. What feedback do you give them on improving their graph? So think about this graph. What is it trying to show? What do you think it should show? And how can they improve it to get from A to B? And feel free to even point out things that it is like really terrible at or really good at. Axis is on the wrong side. No axis labels. Yep, definitely. You have to read the smaller text to even know that this is money and like major takeaways. Yep, exactly. What does this mean? Who cares if McDonald's has 41 billion sales? What does that mean for the company? What should we do next? Yep, axis and labels, definitely. Yep, more details. What's the title? What is it trying to show? How about thinking about the actual oh yeah, which year? Or is it even over a year? We actually don't know what the time frame is here. It could be over a month. Which country? Yeah, is it global? Why is it compared to Afghanistan? Is this all in Afghanistan? Is it sales? Yep. The logos are pretty bad, might be better. Totally. This is an example of doing something too complicated that could be done simply. For example, the McDonald's logo is so wide, even though the height is what matters. So it looks like McDonald's is like 10 times or like 50 times some of these competitors when it's only like maybe like double or even less than that. So think a lot about like the scale and if people, are you misinterpreting data? Does every image need a numeric label? Yeah, it's definitely a lot of text that is hard to read. Is both the width and height? Yeah, Totally. Sometimes people will misinterpret like your graphs. You have to really make sure it's clear and conventional. Yep. Yeah. Keep it simple. It'd be hard to add more data points. Yeah, you have to find a new image and like figure out where to insert it. Super complicated graph. Cool. So we're gonna move on to the next question. I feel like everyone got an understanding of why this is not the best way to represent data. Oh. Cool. So you work at a data scientist at a US car company. You are planning to advise the CEO on which cars to prioritize marketing. You only have this graph. What are your recommendations? Or what more, if any, data do you need to make a recommendation? This is kind of a loaded question. There's a lot of ways to answer this, but I just encourage everyone to remember their visualization best practices and really like think about like, what does this data represent? And is it really the most useful thing to make a recommendation? Yeah. What does frequency refer to?
That's a great question. Because it could mean a lot of things in this context.
Yeah. And yeah, sit-ons are selling well, maybe investing more. I guess another question is this even sales? We don't know what frequency refers to, like we said before. It could be even like trashes, like cars that aren't being sold. Need data on amount. Yep. Direction of marketing dollars spent. Yeah, totally. This has nothing to do with marketing as far as we know. Maybe it is marketing, but we don't know. You don't need it. Yeah, that's a huge one. If it's about Europe and Asia, why do you care? Yeah. Sometimes extra data is not meaningful. It confuses people and makes them interpret different things. Other scientific continents. Yeah, also true. Yes. Thinking about your cohorts. Don't just look at top lines sometimes, especially like with things like marketing or like you want to be like in this world, like machine learning is so important and personalization is so important that prioritizing marketing based on the entire country doesn't make sense. Like you can really find ways to split up the data and be a lot more effective and targeted.
And you can also learn more about your product by looking at how it varies across the country, for example.
Yeah. Distribution by origin and type. Yeah, so it's not clear, are we looking at, like, if it's from the US, does that mean it's actually in the US? That's a great question. Cool. So that was our last example. So I think you guys really took in a lot of the info that we talked about in this presentation. So those were like really awesome answers. So we wanted to now ask you guys, like, if you had any questions about what we talked about, our experience as a data scientist, even working at Facebook, or like the kinds of work we do. So opening this up to everyone and what more they want to hear about.
And you can either use the poll or you can speak up here, whatever you feel more comfortable doing.
Ish, do you want to start?
Yeah, sure. Yeah, this is a really good question. One thing I always like to tell people is that working at Facebook as a data scientist is about 50% coding and then a 50% communication, writing up analyses, and working with cross-functional partners. So I support a team, and so does Shreya. We both have our own separate products. And then a lot of our job is to scope out projects that we think could help our product make a better experience for its users. It's a lot of working with the software engineers on their experimentation and launch releases. And it's a lot of working with the data engineers to make sure the data is clean and is as expected. And yeah, it's a lot of working with other people. And like I said, communication is almost as important as the technical part.
Yeah, my day as a data scientist, I'd say I work a lot with engineers. A lot of the work I do is like building test plans and like thinking with like how can we like drive like ranking machine learning tests that can like really like understand like what users value and what not just viewers but also producers, and understanding like what the whole ecosystem of Instagram looks like if we were to like make certain changes. I also spend like maybe like 30%, 40% of the time like actually driving my own analyses that are like usually focused on like product strategy. Like there's an area that's under invested, or like something that's like either like there's either causal evidence or correlation evidence that like we should be like focusing on these metrics, or like if we were to like drive this much more engagement, like these users would like react this way. I can't give specifics unfortunately, but there's a lot of like working with XFN and planning like tests and like product changes, as well as like driving my own analyses. Do you want to talk about the coolest discovery, Ish?
Yeah, sure. Once again, I'm not sure how much I can actually talk about, but one of my coolest projects to date was looking at how certain countries were using our product, and then looking at actual regional differences within a country to see how users are using it. So even though the population across a country might be pretty stable, it seemed like certain parts of the country were using our product way more than others. And my product is actually, when you go to comment on Facebook and a little sticker pops up, that's my product. So some parts of countries were liking stickers more than others. And I actually got to discover why that was and make changes in our sticker content accordingly, which is really cool.
Yeah, I think for me, the coolest discovery, I think, is, to me, it's something that changes people's minds on how a product works. So something that I found is like, I like looked into like what really like gets people to really produce on Instagram. And something that we were focusing on driving in our product was less important than we realized, or it was important, but there was something else that was more important. So because of that, we had to basically rethought of our strategy. Like I worked with directors, and like we basically like had to like go into these presentations with like more information, being like, we actually don't recommend this strategy anymore, and we're going to focus on these other growth opportunities. So I think sometimes like the cool things are like what the result is, not even just the analysis. Most challenging and rewarding parts of your current position. That's a really good segue, I think. We were kind of talking about that.
Yeah, because I was going to say, I think the most rewarding part of my current position is what Shreya was just talking about when you do get to discover something and change people's minds, and then actually see how your insight has affected the business going forward. I think that's really, really rewarding. And even just after performing an analysis and writing it up and making it pretty and like publishing it internally, I feel like that's like a really rewarding feeling too. And it makes you feel like a scientist. And the most challenging part, I think, is actually scoping out the questions. So like the very first step, I think actually scoping out which projects will have the most product impact, and thinking really creatively, oh my God, sorry. Creatively about what questions you can ask from your data and what hasn't been done yet. I feel like it can actually be really challenging, because you have to have like you start with nothing and you try and figure out what to do. But it also leads to the most rewarding parts. So
yeah, I think the most challenging part of my job is trying to prioritize. I think there's like 300 things that we could constantly do at any moment. Like I work on Instagram Explore, and we could constantly change recommendations. We could constantly like think about like like ways that we can like make the experience better for users, but some are like more impactful than the others. And like different people, like my PM, the engineers, will like constantly have different questions that they're asking me about the data, and deciding like what is the most important thing for me to do in this moment is always like a really tough challenge. And like telling people like, hey, I'm not actually going to look into like how much load capacity this new experiment would have, or something like that. Like there's a lot of different things that we have to learn to prioritize. So that's definitely the most challenging thing. Most rewarding part is, I think, when you actually see like the process of seeing like the beginning of an analysis, the plan to like run experiments and do follow-ups and product strategy, and then actually like seeing something launch. I think like that whole process of like working like not just working silo and ranking, like working on analysis, but then like talking with people, like putting the plan to like get this thing in production, and then like seeing it launch is like super cool. And the fact that at Facebook, we can do those things like within a month is really crazy. Isha, I can't.
I can read another one.
Okay, cool.
Yeah. So there's one that says, I was under the impression that unlike traditional science and statistics, which always starts with a hypothesis, data science is all about figuring out what the data tells us and then form a hypothesis. Any thoughts? So yeah, that's a really cool point. In my opinion, I do think that starting with a hypothesis is a really good way to approach analysis. I think it's because it will guide the direction that your analysis is going in. And one thing Shreya talked about is even if your analysis proves wrong, or even if it ends up being irrelevant to your final insights, just creating an analysis is a good way to start exploring the data and start looking for anything you can find.
Yeah, I think you should put it right that like starting a hypothesis is a starting point. Like if I were to like look at a product and just be like, I'm just going to start looking at the data and see what I find, you're going to spend like days and weeks on like finding something interesting. And like, so you have to really start with the hypothesis. Your hypothesis could even be something like using this recommender would do better. Like it doesn't have to be super specific. Like you don't have to be like this specific thing will have like this like accuracy, or like this will like improve user behavior by X%. You don't have to be perfectly correct, but even having a starting point that could be like completely wrong is really helpful to just figure out, okay, what do I actually care about, and like what outcomes do I want to drive here.
Yeah, and like with the car example kind of from earlier, even something as simple as like this country will have more sales because it historically has more sales, just like we said, like as a way to begin, because otherwise you're just diving into the deep end and it's not going to be as helpful.
Mm-hmm.
Another good one. What is the most difficult part of communicating insights you found?
Did you say difficult? Sorry, I didn't hear that perfectly.
Yeah.
So personally, from my experience, I have a really hard time synthesizing it. There's so much data. Like as data scientists, like we pull so much content. We'll like do the summary stats, we'll like cut the summary stats, then we'll do like follow-up analyses to like cut those stats, and we'll just like keep diving. And then like if we showed that to someone, they'd be like, what a mess. Like what does all of this mean? So because of that, like I have a really hard time because all I want to do is like share every single thing I found. And I found that sharing everything is actually like sharing nothing, because then people don't know how to digest it, and they'll like ask 200 questions, they'll interpret it wrong, they won't know what to take away from it, and they won't drive any changes to the product. So I have a really difficult time like literally taking content out of my analyses, because I'm like, this doesn't drive the point as much as like some other things, even though it's important for context or understanding the product. So that to me is really difficult, because you put so much work into it and then you show like 3 graphs and it's like, wow, did I actually do anything? But in reality, like the impact is more important.
Yeah, I think I agree completely. I think it's a really valuable skill to translate your analysis process and like how you got there to what the user or like what your reader needs to know. And I think one strategy I like to do is sometimes when I'm done figuring out everything I need to, on each separate post-it note, I'll like write a little insight or like a little graph of everything I found, and then I'll like physically like group them into like sections and like create a story based on that. It's almost like writing an essay where you need to have like your overall take, your like body like paragraphs, and then your like conclusion. So yeah, translating from like this is how I got my conclusion to here's what you need to know and how it affects is definitely difficult, but it's a really like rewarding skill as you learn it. And another question, what types of backgrounds do data scientists typically have? Are they usually computer scientists and mathematicians? Have you personally encountered data scientists from non-conventional backgrounds? You can start.
Yeah, that's a good question. So I'll give a brief understanding of like Facebook data science. So we have essentially like 3 types of roles. We have the product analytics data scientist, we have a data engineer, and we have an ML, machine learning engineer. Generally, the data scientist will be kind of like a partner to the PM, and like really like we're a partner to the PM and engineers, and really like make that connection between like the product strategy and the like engineering strategy, and like really like drive insights that can improve both. And then the data engineers will work on the like the resource, like the actual like sources of data, and like making sure it's really validated and really like usable. And then the ML engineers will work on like basically like building the models and improving the models and really like making sure like our personalization is the best way. And everyone works together, and the jobs like have kind of like a blurry line between them. So because of that, the archetypes kind of differ depending on the role. Obviously, you can imagine that an ML engineer is very CS heavy. We have a lot of like machine learning, PhD candidates, and we also even have like regular like computer science people who like just like did a lot of like software engineering experience and became machine learning engineers. For data scientists, like the traditional product analytics data scientists, we tend to weight statistics really heavily, but we also care a lot about product sense. So if we were to ask you just like break down a product and how would you like think about like what the user experience is and like what do you think are the most important like things into factors of a user experience, and how do you break those down into metrics and goals and like analyses? That's what the important skills. So I have seen people who came from like literally like language analysts. I've seen graphic designers. I've seen like computer scientists. A lot of people who just have built up that context and like know what's it like. How do you break down a problem? Even economists, like a lot of these people perform really well because they know how to break down problems and really like think about the users or like the key stakeholders in any environment. And data engineers tend to have pretty strong statistics background, but they also like are a little bit more engineering heavy.
That was awesome. I don't have too much to add other than that. I do think a non-conventional background is like a really great way to enter data science as well, just because you do learn that product sense from wherever you are working. And so it's definitely possible, and I've definitely encountered them, and yeah. And I don't think we have any more. Oh wait, there's 5 more responses, never mind. Are there any ways data scientists make good decisions while using less data to preserve privacy? So how to make decisions using less data? Yeah, do you want to go ahead?
Yeah, I think like privacy is always the most important. So you should always go into your analysis thinking you're not going to use anything that would basically infringe on other people's privacy. So Facebook, like within our tools, we already have settings that doesn't let you see the data of like anyone you know through your social graph on either Facebook, Instagram, or whatever app. And you should never really need to infringe on that, because generally like if your products have like large enough numbers of people, then you don't even need to see that content to like be able to make analyses. We also have like goals on like data retention. Like you can only keep data with people with like on like specific users data that it wouldn't even you wouldn't even know like who the user is, but even like having like user data, like specific behavior by specific users, can only be a few months old. And then anything beyond 3 months has to be like aggregate by like country or something like super large. You can't really like pick out specific countries. So you should always operate within those bounds and think about like, how can I use the data that I have within my access that wouldn't infringe on other people's safety? And also try to avoid collecting any like user information that would be like names, email addresses, like locations, like avoid anything with that kind of data because you're probably not going to use it.
Yeah. And the only thing to add is usually data scientists are doing more like quantitative analysis. So they're really looking at like summary numbers and such. But if you ever do more qualitative analysis where you are looking at people's data, like there are a lot of good practices, like Shreya was saying, about making sure everything is very anonymous. And you can also respect people's privacy by like using your own summary words of everything you see rather than getting too specific about anything. But yeah, okay. How does Facebook come up with the care reaction? Does Facebook run intensive A/B analytics first? Yeah, so the care reaction was actually my team, since I'm on Newsfeed Experience, and it came together very, very quickly because there was so much going on with quarantine and coronavirus, and it really just was somebody had the idea like, oh, what if we included this? And then we didn't run any A/B analytics on, oh yeah, sorry. We run A/B analytics first on just releasing like the actual test feature to make sure that it works and that there isn't like bugs in it. But from a data science perspective, there wasn't too much to launch it. There's more analysis to do afterwards. Yeah. The only thing to add for this is for this actual care reaction too, like the content strategist and the whole team was just brainstorming what should we call it? Like, should we call it like loving reaction, or should we call it like warmth reaction? And it was kind of fun, but yeah.
I think I would add that like a huge part of the data science job is actually like building these A/B experiments. I think like anything we do, like we have to do an experiment for the most part, unless it's like really important that we get network effects. So like if there's something we can do that we can either like randomly sample a part of the population and like get a good idea of how it's working, then we run A/B tests. We run it, like every single person in this room probably is like in like 200 different tests right now at least, and like everyone's in a different experience. So there's always tests going on. Sometimes there's specific tests that like we can't really understand the full effects if we just like picked 1% of the entire world. So we'll sometimes do tests like within a specific country, or we'll like do it based on the phones instead of like the people. And there's like a bunch of different experiment techniques. And actually a huge part of the job of data scientists is telling engineers like, this is how we want to run this test, and this is how we're going to analyze the results. And this is how like, and even like a guidance on like what does stat sig mean? Like how should you look at like how big should the sample size be? Like all of this is part of the job, and like stuff that I do like on a day-to-day basis.
Yeah, absolutely. Okay, what tools and programming languages do you use the most? So a cool thing about working as a data scientist too is usually it doesn't matter what languages you use, it more matters what your output is. And that's not true for all companies, but I know it is the case for Facebook. I use a lot of SQL to pull data and just to do quick ad hoc analysis, and then I do all my longer analysis in Python and in R.
Yeah, I use a lot of R and SQL. A lot of people use Python. Generally, you can do like almost everything within those tools, but and I think some people use Spark too.
What are the strategies Facebook uses to gather data? Strategies.
So
well, yeah, go ahead.
I don't know if we would call it strategy, but anytime we launch a product, we think a lot about like one of our first thoughts right after we decide this designs is how do we log that? Like we need a way to get those actions into the data set, because at the end of the day, if we can't measure a product, it doesn't mean anything to us. So we need to measure exactly like how much usage it is. Like we need to run an A/B test on like what are the effects on users if we add it. So we need to log every single action. So generally our strategy is like, well, like a lot of like engineers and data scientists and data engineers will coordinate and be like, okay, what are the most important like what are the most like important events that we need to log every time like someone uses this feature, and like what would we use in our like measurement of like an experiment to evaluate if it was a good product. So our strategy is generally think about like what is the best way to measure the usage, like the impact of the product, and that's how we decide like what data to collect, like what events to use, and like what metrics to build for our experimentation.
Yeah, I don't think I actually have anything to add. Okay, this looks like a follow-up to what we were talking about earlier about hypotheses. So it's more important to have possible questions and favorable outcomes than have a hypothesis.
Could you repeat that? Sorry. It's more important to
have possible questions and favorable outcomes rather than a hypothesis.
I think that's fair. I think having a question, like you don't have to have like an exact opinion on a question. But I do think like that probably means your hypothesis isn't developed enough to if you don't have one. Like I think hypotheses can be like pretty high level. Like even something like this new product would be useful. It doesn't have to be super specific. I think like generally at Facebook, we like to be very hypothesis driven because it avoids us getting into a world where we just like start launching a bunch of products because we just want to try it and we just want to see how the data works. So we need to have like a specific reason to do it. Because especially like we know that our like experience on the app is really important to users. And if we do something that they don't like, they're going to immediately like turn off and find another app. So if we don't have a reason to do something, we generally don't recommend like complicating the user experience. So that's why we really care about hypotheses. It's not because like we care about like specific opinions being right, but more just we want to make sure we have a reason for everything we do. So I think it's valid that like some analyses you just have questions about the product, but I would ask yourself like, why are you asking those questions in the first place? Because you generally have an answer for that.
Awesome. And our last question, with the US elections approaching, what role do you think data scientists will or can play in dealing with the spread of misinformation, not to mention the misinformation surrounding COVID-19?
Ish, could you repeat the question again?
With the US elections approaching, what role do you think data scientists will or can play in dealing with the spread of misinformation, not to mention the misinformation surrounding COVID-19? So how can data help with misinformation? And I think Shreya froze.
Is my answer.
Yeah, I think she's cutting out. Yeah, a lot.
Okay, well, while she's frozen, I guess we can take a quick second to say, now that it's 6:50, we would love to hear feedback from this talk so that we can figure out what changes to make next time when we give the talk in October. So the organizers are going to send a feedback form to the chat. We're all going to take 3 minutes right now in silence just to fill it out. And then afterwards, we'll still have some time to finish up those questions.
Yeah, I think as Shreya told you, if they don't get any like logs for their apps, it doesn't mean much for them. So that's the same thing with us. Like we're trying to look for as much feedback as we can, so we can improve like our datathon. So it'd be really awesome if you all like took like 2 or 3 minutes to fill that form out. Yeah.
Cool. Can you guys hear me now?
Yes, you're back.
Yes.
By the way, the form doesn't work for me. I think it looks like you have to be in the organization to open it.
Okay, I probably didn't undo the Tammy restriction. Let me fix that for y'all.
Thank you. In the meantime, sure, if you do want to talk about misinformation and data.
Yeah. My answer to that would be like data is super important. It's like, how do you know if you're actually improving the spread of misinformation or COVID misinformation if you don't have data? I've worked with a lot of data scientists who are on this piece of work, and generally like the data scientists are the ones like coming up with the measurement tools. Like how are we actually, if we like run an experiment, how do we know that we actually like improve the experience? They'll both like, first they'll create like the strategy, like what types of like how are we gonna like how do we even like break down what misinformation means? Like how do we develop a strategy around it? And then they'll think of like what are our measurement techniques? And then they'll like figure out like, okay, like how are we actually gonna, now that we know how we're gonna measure it, like what strategy should we use to actually like reduce the spread? So like I'd say data scientists are almost like more like so core to that process, like it's insane. Like so I think it's super important, and I think like being able to think about these large questions and think about like that entire like flow that I talked about is super useful.
Cool. And while we're still waiting for time, we have one more question, which is, oh, it just got covered for me. Do people move around often between the different data science, data engineers, and PM roles? Where do you see your careers going moving forward? I haven't seen a lot of movement around, but I do know that it happens. I guess I see my own career moving forward as continuing to do data science until probably switching into a PM role eventually. I do think that data science gives you a lot of practice in a product sense, and I think it sets people up well for other roles as well.
Yeah, I've seen a couple of people move around. Generally, like you really have to know that's what you want to do to move roles, because like it is not super easy to move roles, just because like, you know, so, like sometimes like you have to deal with like sometimes you get under leveled because you're not as you don't have PM experience, like because it's, you have to really know that's what you want to go into. But it happens. It totally happens. I've met a lot of people who've done it. In terms of where I see myself, I think I really want to build up technical skills as a data scientist. I think like that's like what makes us really useful to any company and marketable. So I'm focusing on becoming like a really like senior data scientist and like growing within like this role, and then like maybe thinking about like management and like building a data science department at other companies and stuff.
Yeah, and I think also once you have built up a lot of data science experience, you start seeing data everywhere, and you start seeing how you can use your skills to like improve so many different other fields. So the questions about misinformation for voting, there are a lot of data scientists working for the DNC and for even local governments and school committees. There's a lot of ways that data science can help there. So I think that's another way you can grow your career. And now the feedback form should be working. So if everyone can go back to that link and take 3 minutes to fill it out, it'd be super helpful.
Yeah, by that time, I did have one question for y'all. Yeah. So when it comes to just like logging data, I would think that there would be a need for like people to actually build those pipelines. So and I would assume that it's not y'all that are doing that. So do you have to actually like work with engineers and kind of tell them that, oh, these are the things that we want to log and okay, so I guess I just answered my own question. Cool.
Yeah, that's exactly it. Like you talk to the client engineers, like the iOS and Android engineers, and you're like, these are the events that we need to log. This is like the additional data you need to log with it, like where on the app it happened, etc. And then the data engineers build it into pipelines and tables that are usable, and then we get the beautiful magic of the data.
Yeah.
Cool. So how often does that actually block you from being able to do like productive work?
Anytime you build a product, if you don't have logging, you might as well not launch it. So that's generally like, we will not launch a product unless the logging is there, which is, I think, really cool about Facebook is like how much we value analytics to like actually block a launch of a product because we don't have it.
Yeah.
Cool. Thank you.
Mm-hmm.
I think there are a few more questions on that, or I think there's just one more question on that if you all want to answer that. I think it just says, any suggestions or tips you would like to give us?
Keep yeah. keep practicing projects, and I think that I talked about this in the earlier session as well, but any project you do, make sure you practice all best practices as you make it. So like create like a full analysis, make sure that you have your impact really well written, your visualizations are great. Like if you're gonna practice something, and I think it'll pay off.
Yeah, I think like doing projects, practicing like the new techniques, like working with different data, I think all of that's super helpful. Yeah, that would be my advice.
Yeah. And if you could go back again, interning, school, or past few years of work, what would you do differently, if anything?
I would take more economics classes. Weirdly enough, like we use the terms like elasticity, Gini index. Like we use a lot of like economics terms when we talk about like just like personal, like even there's like when we talk about ranking, like are the rich getting richer on Instagram? Like if that's like, we need to think about these kinds of things. So we think a lot about in terms of economics. So I think like an understanding of how the world works. So psychology, economics, I think that would be really helpful in my role. And I like learning more analysis techniques throughout life is always helpful.
Yeah, no, I think I completely agree about taking economics classes, and just more business classes in general. And I also think that, especially like while you are still in school and while you are still in all these like amazing classes, like really taking great notes and packaging up those notes and making sure you can go back and reference them, I think is super valuable. I felt like I learned a lot of cool things at school, and I wish I could remember all of them all the time. So keeping really organized with your learnings, I think would be a good tip. And yeah, that leaves us with a minute.
Yeah, I think we should be good to close up now. Thank you everyone for being here. Thank you, Isha and Shreya, for running this talk. It was awesome. And I hope you all enjoyed the bootcamp, and I hope to see you all in the Datathon in October.
Yeah,
Thank you so much.
Cool.
I hope this is
See you.
helpful.
Yeah, definitely leave us feedback. We'd love to learn more too.
Thanks everyone for being a part of our first ever boot camp. We're so excited. So thank y'all. Hope you have a good rest of your night.
Bye.